Okay, yeah, this is another video for Newton's second laws now, the Newton laws. So I think this is November 2022 paper, grade 11 Newton laws, question 3. Yeah, so you can check on the internet for this question if you want to get the source of it. So let me read the statement. The statement says 2 blocks of mass 5 kg and 2 kg are connected by a light inextensible string. A force F is applied on 5 kg at an angle of 20 degrees to the horizontal, and the system of blocks accelerate to the right at 2 meters per second square. So they gave us the acceleration. They said it's 2 meters per second square, and the system is going to the right. And then the kinetic frictional force of the 5 kg block is 10 newtons. So we do have the kinetic frictional force for 5 kg. It is 10 newtons. So this is the information that they gave us with 2 blocks. Now, before we go to the questions, okay, let's go to the questions, because if I wanted now to start explaining the free body diagram of both blocks, but anyway, they will ask us the free body diagram of the 5 kg. So 3.1, if you check your questions now, 3.1 says define the term the normal force. Define the term the normal force. Now the normal force, the table here is applying a force to that 5 kg block. We call that force the normal force, and the block itself is applying a force on the table. We call that one the weight. And then the table, between the block and the table, there is a friction. That is a friction. And there's also a tension between the 2 kg block and the 5 kg block. And then there is that applied force at an angle of 20 degrees. So we have these 5 forces that are acting on this block. Now they said now we must define now that one, which is the normal force. What is a normal force? You can easily say the normal force, 3.1, the normal force is the force that the table or the surface exerts on the object in contact with it, and it is always perpendicular to the surface. So this surface, this table is exerting a force on the object, and you can see that force, this force, the normal force, is always perpendicular to the surface. So this is your 5 kg block. Yeah, so that's how you define the normal force, is the force that the surface exerts on the object and it is perpendicular to the surface. 3.2, draw the free body diagram of all forces that are acting on the 5 kg block. The forces that I've just drawn here. So what you do, you just make a representation of the object as a dot. So you just make a representation of an object as a dot, like that, and then you have now that diagonal angle, the diagonal force, which is the force of F, and then you have the horizontal force backwards, which represents the tension and the friction. So that's the tension, that's the kinetic frictional force. And then you have another going down, which is the weight, and another going up, which is your normal force. So this is your normal force, and this one is your weight. Now you must be careful here when you draw the free body diagram. If you do something like this and then you say that's a tension, they will penalize you. Or if you say this one is the frictional force, which is with a capital letter, they will penalize you. So you must be careful there when you do your free body diagram, that you don't do this silly mistakes there. So yeah, so this is how you get your 5 marks for all your forces, So that's 1, 2, 3, 4, 5. Now you don't have to do this, but I sometimes encourage learners to do this. This force has 2 components. There is a horizontal component, I'll call it F of X. There is a vertical component going up, I'll call it F of Y. There is no marks for these 2 components of F, but you just have to show them so that when you do your calculations you won't forget that there are the 2 components there in case you need one of them. So let's look at the following question. 3.3.1 calculate the tension in the string. Calculate the tension in the string. Now they want us to calculate this one, the tension. So we want to find this one, which is the tension. Remember, they gave us this one, they said it is 10 newtons. Also we have that F of X, which is the horizontal component of the weight. So there are 2 ways you can do this. Before we answer this one, let me quickly draw the free body diagram of the 2 kg block. Remember, there is this block now, the 2 kg block. The 2 kg block, the hanging object always has 2 components. There is a weight and there is a tension, because it is being pulled up by the 5 kg block, but it is also hanging towards the earth. So the 2 kg block has these 2 forces, and the tension of the 2 kg block is equal to the tension of the 5 kg block. So these 2 forces, T2 and T5, are always equal but in opposite direction. So if we can find the T2, then we would equate it with the T5 because of they are equal but in opposite direction. So you can easily find the T2 because of there are only 2 forces there. So let's do that one. So I'm going to say 3.3.1. 3.3.1. Let's take up as positive. You always have to identify the direction before you solve your problems. Up is positive, so we say F net is equals to MA. Where are we looking at? We are looking at now the 2 kg block with 2 forces. There is a force going down, which is the weight of the 2 kg, and there's a force going up, which is the tension of the 2 kg. This is a 2 kg block. So we know this force, which is the weight, is equals to mg. So if we take up is positive, that means T, which is a tension, is positive, and the weight is going now down, it will be negative. So the F net means the sum of these two forces. So we say T, which is positive, minus the weight, which is negative, equals to ma. Remember, they gave us the acceleration. They say the acceleration, I think, is 2 meters per second. The acceleration, yes, is 2 meters per second. So we do have the acceleration. So we want now the tension. The weight is mg. So the mass is 2, the acceleration is 2. And then T is equal to, the mass is 2, G is 9,8. 2 times 2 is 4. Then 2 times 9,8. 2 times 9,8 I think is 19,6. I think it's 19,6. Yeah, it's 19,6 equals to 4. Then we take this value, put it on the right. So you have 4 plus 19,6. 4 plus 19,6, punch on the calculator. 4 plus 19,6 is 23,6. So the tension is 23,6 newtons. Now this tension is going which direction? It's going upwards. So that is the tension for the 2 kg block. Now let's look now the other question. The following question is 3.3.2. Calculate the force F as shown in the diagram. Calculate the force F as shown in the diagram. In other words, they said we must find now this force F. Okay, so let's go back to our the freeboard diagram for the 5 kg block. So now we're looking for this force, which has 2 components. Now for the Newton's second law, when you apply the Newton's second law in the 5 kg block, we are going to focus only at the forces. Remember, the Newton's second law says when a force is exerted on the object, when the force is exerted on an object, that force, it causes the object to accelerate in the direction of the force. So it causes the object to accelerate. To accelerate means to move. So that is the first part of the Newton's second law, and we know this acceleration is directly proportional to the force, but it is inversely proportional to the mass. Now I want us to look at the first part of the law, that when you apply a force, this is a force that is applied on the object, and it causes this object to move in this direction. Now when the force is moving, the only forces that are causing this object to move is the horizontal forces. It is this one, and that one. F of x is causing it to move forward, but the friction is opposing that motion and the tension is opposing that motion. So these two forces, the normal force and the Fy and the weight, are not causing the object to move, because these two are pushing the object upwards. This one is pushing the object downwards. So that's why the object is stationary, or is it flat on the surface, because these two are equal to this one. In other words, the normal force is equals to the normal force plus Fy is equals to the weight. So I'm not going to focus on these vertical forces because they are not being applied by the Newton's second law. So I'm just going to focus on the three forces that are causing the object to move. The one is causing it to move forward, the two is causing it to move backwards or in opposite direction. So I'm looking at F of x, friction, and the tension. Now this F, the F of x, this F of x has a formula of F cos of theta. So they said now we need to find the magnitude of that F, because if I already know F of x is equals to F cos theta. So if I know this magnitude, then I will know what is that force. So let's do now a calculation using the Newton's second law. 3.3.2. I'm gonna say, remember we said up is positive, that means right is positive. Right is positive. If right is positive, that means that left is negative. So this is our direction. So 5 kg block is moving to the right. So I'm going to look at now at the sum. Remember, F net means the sum of the horizontal forces only. I'm looking at the sum of the horizontal forces only. I'm not looking at the vertical forces now. So we said that there are three forces now that are horizontal. There is F of x to the right, friction is to the left, tension is to the left. So F of x is positive, friction is negative, tension is negative. So I'm gonna say F of x is positive minus frictional force, kinetic frictional force is negative, the tension is negative, equals to ma. And we said F of x is F cos theta minus the frictional force minus the tension equals to ma. Now let us substitute now. We want F cos, what is the angle? The angle is 20 degrees. The angle is 20 degrees. So we have F cos 20 degrees minus, they gave us the friction of the 5 kg block, they said it's 10 newtons. The tension now, we said the tension of the 2 kg block is equal to the tension of the 5 kg block. This one is positive, then that means the other one is going to be negative because they are in opposite direction. Equals to, this is the 5 kg block, the acceleration is 2. So we have F cos 20 degrees. So minus 10 minus 23,6 I think is minus 33,6. 5 times 2, that's 10. Then F cos of 20 degrees is equals to, now we take now that 33 which was negative on the left, we put it on the right, is going to be positive. So it's going to be 43,6. Now here we have F cos of 20 degrees. So we divide by cos of 20 degrees. We divide by cos of 20 degrees. Then we can get the F. So let's check this one. So we have 43,6 divide by cos of 20 degrees. So we get 46,40 newtons. Now this one is also moving to the right. So this is the magnitude of the force, is 46,40. That is the magnitude of that diagonal force. Now let's look at the last question. 3.3.3, the coefficient of the kinetic frictional force of the 5 kg. The kinetic coefficient. Okay, I think this one we have to use the kinetic frictional force formula, this one. Now we need now to calculate this coefficient, the kinetic frictional force coefficient. We do know the frictional force is 10, so now we need to find the normal force. Now I said that on that 5 kg block, the normal force plus Fy are equals to the weight. In a stationary object, normally when you have an object on the surface which is just stationary there, the weight of this object is normally equals to the normal force. In this case, we said the normal force is equals to the weight, which means that the normal force is equals to mg. But now when you have something like this, you have an object with a diagonal force acting on the object. Now you can't just say the weight, the normal force is equals to the weight. That is incorrect in this case, because this force has another vertical component which is Fy and another horizontal component which is Fx. So in this case, the normal force and Fy are both moving in the same direction. So we say the normal force plus Fy, they are going up, they are positive, but the weight is going down, which is negative. So then the normal force in this case will be, take W to that side is positive, take Fy to that side is negative. So that means the normal force is equals to the weight minus Fy, which is F sine theta. So we have this formula now for N, for the normal force. So let's apply that formula here. So let's apply the formula here. So we say N is equals to mg minus F sine theta. So let's quickly say, okay, we do know the value for this one. I think it's 10. The value for the frictional force is 10. The magnitude, we want the kinetic frictional force. Mg is 5 times 9,8 minus f of x. We do know f of x now, it is 46,40 sine, the angle is still 20 degrees. Now, even if you are wrong here, there will something that they call positive marking. They would give you the answer for this one. As long as you substitute this one correctly, the value of the force, they will give you the mark for that one. So we have 10 is equals to the kinetic frictional force, 5 times 9,8. 5 times 9,8 is 49 minus, then we have that one which is 46,40 sine 20 degrees. You must make sure your calculator is in the degrees. So it's 15,87. 15,87, and then we must subtract the 2. So we have 49. In fact, here we're not supposed to round off here. Okay, let me not teach you incorrect mathematics. Okay, let me erase this. Let's do that one again, so that we don't go out of the range. Let me give you the correct answer. It's 46,40 sine 20. So we need to write all of that answer here. So it's 15,869.73 86973 465. Yeah, so we write everything down so that we don't go out of the range. We will round off in the last answer. You don't round off in the middle of your calculation. So then let's just subtract 49 here. We know the answer is positive 33 comma 130265 comma 130265 35. We're not going to round off. Then we'll divide by all of this value 26,535, and also on the right 33.1330 26,535. So let's find now. This one cancels. The kinetic coefficient now is equals to 10. So we have 10 divided by 33,13026,535. Then the correct answer is 0,30. 0,30. This is the correct answer. Now, that is the kinetic coefficient of the surface. Okay, that's the end of our question. Then I guess I will see you in the next question, in the next video.